Good morning. Chapter 13, Lesson 5 is on page 596. We're going to be using quadratic equations. These equations are going to be set to 0 or to something on either side. There will be an equal sign that we're going to have to deal with. Let's start off with something like number 17. 2 divided by y minus 1 plus 3 times 3 divided by y plus 1 is equal to 1. And we know all of a sudden, automatically, hopefully, that our LCM is going to be y minus 1 times y plus 1. So by now this is kind of old hat for you folks, so that we're going to crisscross. So we have 2 times y plus 1 plus 3 times y minus 1, all that divided by y minus 1 times y plus 1 will give us just y plus 1, y minus 1 in the numerator, remember the LCM, and y plus 1 and y minus 1. So we multiplied everything on both sides by the quantity y minus 1, y plus 1, so that we could have the same denominators, and luckily, since they are the same, we can wipe those out. We won't have to deal with those. So this looks like 2y plus 2 plus 3y minus 3 is equal to y squared minus 1. If you FOIL the stuff on the right side, we know y plus 1, y minus 1. So if we combine like terms, we have 5y minus 1. That turns out to be y squared minus 1. Let's see if we can use our zero product property. So 0 turns out to be y squared minus 1 minus 5y plus 1. Or 0 turns out to be y squared minus 5y, which is y times the quantity of y minus 5. And with our zero product property, we end up with y is equal to 0, or y is equal to positive 5. Let me erase that, make sure it looks like a 5. So those are the two solutions for number 17. We use our zero product property. Either y is equal to 0 or y minus 5 is equal to 0. And when we solve for y, we ended up with 0 and 5. Number 35 is an error analysis, and it says, who is this? Leah went ahead and did this problem, and she came up with a solution so that the discriminant was negative. Let's see where she went wrong. So again, we're going to have to come up with an LCM, and I think the LCM for this one turns out to be x times x minus 2. And we're not going to have to solve it. All we're going to have to do is get the discriminant and take a look and see what those values are. But first, let's do some more crisscross. So we have x squared minus 3 times x minus 2 divided by x times x minus 2. Turns out to be 4 divided by x times x minus 2. I made my LCM x times x minus 2, so I crisscross the x times the x, numerator denominator, minus numerator times the opposite denominator, and I got the same thing. So I can cross out my denominators, thank you, because they're exactly the same. So our equation looks like x squared minus 3x plus 6 is equal to 4. Or x squared minus 3x plus 2 is equal to 0. Remember, we want to use that zero product property. So we remember the factors. Oh, we don't even have to factor. Let's just play with the discriminant, ax squared plus bx plus c. And we find out that a is 1, b is negative 3, and c is a positive 2. And all we got to do is play with b squared minus 4ac to see what kind of SIGN we're going to have, either positive, 0, or negative. So this looks like a 9 minus 4 times a 1 times a 2, which gives us a 9 minus 8, which gives us a 1. So the discriminant being positive, Discriminant. Positive means I have two real roots. So if I draw my little rudimentary picture, my roots would look something like that, and my answers would be those two things. So she made a mistake in doing the discriminant calculation. The answer came out to be positive, and there were two real roots. Thanks so much. We'll see you all tomorrow.